The next topic is empirical and molecular formulae. So first we will go for the definition of empirical formula. The definition says that it is the simplest formula of a compound having atoms of different elements or different kind in simplest whole number ratio. Second definition will be of molecular formula. It says that it is the formula of a compound having actual number of atoms of different elements. There is a relation between molecular formula is equal to empirical formula into common factor. Common factor is calculated from molecular weight upon empirical formula weight. Either you put directly common factor or you first calculate the common factor using the formula molecular weight upon empirical formula weight, then we put the values. So here there are some molecular compounds, right? Their common factor or their empirical formula, like C2H4, the common number is 2. That is called the common factor. If we divide these numbers of C2H4 by 2, we will get the simplest formula, that is CH2. In this formula, carbon and hydrogen has simplest ratio, that is equal to 1:2. Now we are taking C2H6. Here is also common 2. Then empirical formula will come 3. C2H2, the common is again 2. The empirical formula will be CH. Another is C6H6. The common factor is 6. Again the common empirical formula will come CH. Another we are taking C6H12O6. The common factor is again 6. The empirical formula will come CH2O. Another we are taking CH3 COOH. We can write this CH3 COOH as C2H4O2. Here is a common factor 2. The empirical formula will come CH2O. Another we are taking C2H4H2O4. Common factor is 2. The empirical formula will come CHO2. Right? Now we will solve the questions of percentage composition, and by calculating the percentage composition, we will calculate the empirical formula of a compound. Here we are taking a question. Question number 1. An organic compound has oxygen 26.24% and hydrogen is 4.92%. Question asks, calculate the empirical formula of the compound. So because it is organic compound, so it must have carbon in it. We have oxygen is 26.24. Suppose it is gram. Hydrogen is 4.92 gram. Then carbon will be 100 minus 26.24 plus 4.92 gram. Now, the amount of carbon is coming 68.84 gram. After calculating the amount of carbon, hydrogen and oxygen, that is all the elements, we will then make a table. The table will be, first we will write element, then percent or mass, then atomic weight, then atomic ratio, then your simplest ratio. So here we have three elements: carbon, hydrogen and oxygen. Carbon amount is 68.84 gram, hydrogen is 4.92 gram and oxygen has come 26.24 gram. The atomic mass of carbon is 12, hydrogen is 1, while oxygen is 16. Atomic ratio, that is gram atoms, or we are calculating moles. 68.84 upon 12, 4.92 upon 1 and 26.24 upon 16. It is coming 5.74. It is 4.92, no change. It is 1.64. So carbon is 5. Gram atoms of carbon are 5.74. For hydrogen they are 4.92, while for oxygen it is 1.64. To calculate the simplest ratio, we have divided all the values by smallest fraction among them. The smallest value of gram atoms, that is atomic ratio, is 1.64. So we will divide all the values by that 1.64. So 5.74 upon 1.64, 4.92 upon 1.64, 1.64 upon 1.64. It is coming 3.5. It is coming 3 and it is coming 1, because one value is coming in fraction. Whenever in any question any simplest ratio is coming in fraction, to make it as a whole number we have to multiply all the values by 2. So this is that carbon is coming 7 unit, hydrogen is coming 6 unit, and oxygen is coming 2 unit. In this way, empirical formula of the compound is C7H6 and O2, isn't it? So this is the first question for calculating empirical formula. Another question we are taking here. Another question we are taking. The question is, question number 2. Ramesh heated 11.2 gram of compound X, atomic weight 56, with 4.8 gram of Y, atomic weight, its atomic weight is 16, to form the compound. The question asks, calculate the gram atoms of X and Y. Second part, find the empirical formula of the compound, right? So here we have X and Y. Weight of X is 11.2 gram and weight of Y is 4.8 gram. Atomic weight of X is equal to 56, or atomic weight of Y is equal to 16. Question asks, calculate the gram atoms. Now we will calculate the gram atoms. So number 1, gram atoms of X is equal to weight upon atomic weight, that is 11.2 upon 56, it is 0.2. Second, gram atoms of Y is equal to weight upon atomic weight, and it is coming 4.8 upon 16, that is 0.3. So in this way, both X and Y have the ratio 0.2 is to 0.3, and the simplest ratio will be 2 is to 3. In this way, the empirical formula of the compound will be X2 Why 3? Because the ratio of x is 2 and ratio of y is 3.